Hey, Shasta High School, this is Mr. Roberts in room 309 here at Shasta High School, AB Computer Science. We're going to start today with a pretty solid review of what we did yesterday. I want to slow that down a little bit, and then we're going to move on and extend our work. The project I'm giving you today does have two extra objects down here. One is called a word list tool, and another one is a word list.txt. And basically, the purpose of these we'll discuss a little bit later. But if I open up the word list text, this is a longer list of words. And it's just going to give us the ability to look at maybe a more interesting data set. Because when we're literally typing in the words ourselves, it's kind of hard to make it seem purposeful. So there's two tools we'll talk about in a minute. Let's open up Words. It is a completely empty project, right? So inside of Words, we're going to start with the fact that this is a class, right? I'm going to skip one line. You know why? I think you know why. But we'll start with public words. Oh, public class words. That makes sense. And it should be capitalized. And nothing, no braces or parentheses there, but we do have an open brace, enter, enter. All right, so everything within this class lives within these braces. This is where it begins, and this is where it ends. This is going to make use of the array list, so we're going to go ahead and import that now. Import, and then java.util.ArrayList. There's one other thing that we're going to need, and it's going to be when we go ahead and grab our bigger list from the other tools, we're going to need an IO exception. So please, this is not part of the AP subset, but I want you to also import java.io.ioexception, input output exception. So now we can get into our class. And inside of here, I am going to go ahead and initialize a field variable. It's really a good idea to make these private. So private, and the field variable is going to be going to be an array list. This is the new syntax from this unit, array list. An array list of string objects, and I'm going to call it words. It's a little confusing, but this is going to be all of the words that I hold, right? So it's in a class called words, but it's a collection of words with a lowercase words. Probably a bad naming convention. I might regret that someday, but for now, it seems right. So semicolon, new line, and we are now into our constructor. So again, field variables should always be private. You can see mine is private. Then we have constructor, so our constructor is going to be public. The constructor is always the exact same name as the class. There's not a return type. It's not even void. So public words, words. This could have parameters sent to it, so I open, close parens, open brace, enter, enter. There we go. So this is our constructor. In here, we're just going to do something goofy. We're going to add the following 5 words to our list in kind of a funky order. So I want us to do word. You know what? I called it words, didn't I? Words dot add, and I'm going to add the word time. Oops, I need a semicolon, not the letter L. And I'm going to do next words dot add. Let me do words dot add lunch, quote, LUNCH. Okay, and then I'm going to do words dot set. Now, right now, there's only 2 things that I know of that are in my list, and I really should be careful. I should probably be using a dot size to confirm programmatically how many elements are in this array, because the only set I can do is I can do a set 0, I can do a set 1. If I do a set 2, 3, or 4, anything past 1, I'm going to throw an array or index out of bounds error, because set is only capable of writing overriding one of the values that you have. So I'm going to say words dot set, and I want to set the one at index 1 to skunk, S-S-K-U-N-K. Now, I set that, but when I set it to skunk, right, it overwrote lunch. So I had time lunch, but then because I am setting the one at index 1 with skunk, I just lost lunch. Except the return type for set is actually the one that's being returned. So if I was to peek and look at this words dot set, whoops, dot, and I peek at this, and I look at set, what set does is it says it returns the element previously at the specified location. So it did give me back the word that was there, but it's no longer, I didn't capture it in any way, shape, or form, so it's really gone. So just to kind of demonstrate that set does return the element, I'm just going to say, I'll say string temp is equal to words.set1 skunk. So what's funky is set is literally going to become, the lunch is going to pick up this temp. Temp is going to get the word lunch. That's what I mean to say. Then I'll do this. I'm going to say words dot, let me do another add, but this time I'm going to add at location 0. And what am I going to add at location 0? I'm actually going to add temp, T-E-M-P, not with quotes around it, but temp is in the string above. And we'll just do one more thing. How funky do I want the thing to be? Let me do this. I'm going to say words dot add. Okay. Words dot add. I'll just do a straight old add. I'll just do an add hexagon. Yeah, we'll just leave it there. A couple things that I didn't use here is I didn't use the add. Well, I did use add. There's two versions of add, right? There's the add that uses, in fact, we should look at this. Words.add. So when I look at it, there's an add that takes just a string and it tacks it onto the end of the list, right? So it says appends the specified element to the end of the list. If I come down and look at the one below it, it says this inserts the specified element at the specific position in this list, shifts the elements currently at that position, if any, and any subsequent elements to the right, adds 1 to their indices. So everything gets shifted to the right one. This says the index is the index at which the specified element is to be inserted, and the element in this case is the string that we're inserting. That's what dot add does. The two different dot adds. Dot set, whoops, let's look at it. Dot set does what? Dot set says replaces the element at the specified position in this list with the specified element. So I'm going to replace it. The index is the index of the element to be replaced. The element is the element to be stored in that specific location. So I'm going to be overriding it. Now, optionally, I can use this or not. It does return the element previously at the specified position. So we'll see how that works too. I think the only other thing that we'll look at is let's just do a, I'll do another temp. I'm going to say temp because I already put it back. I'm just going to say temp is equal to words dot remove, and I'm going to ask it to remove the one that is at index 1 at this point in time, and I really have no idea what that is. Okay, so in order for us to see what's happening here, I could do like a lot of intermittent print statements, but what I'm going to do instead is I'm just going to go ahead and we'll compile it first of all, yeah, and then I'm going to add a breakpoint right here. Ooh, I noticed I didn't do something right. All these are going to give me a null pointer exception, because although I did create a variable that's capable of referring to an array list of strings, I did not create the array list of strings. So let's make that happen. So I'm going to say words is equal to a new array list of string objects. And then I'm opening, closing parentheses because this is a call to a constructor, and I'm using a semicolon. So that should give me everything. It compiles nicely. Let's set it up so that I can see the debugger happening. Okay, I think I have this all set up so everything will appear nicely. I'm going to right click on words, and I'm going to call the constructor new words. And as soon as I do that, you can see it paused right here. Let's get to where I can see the actual code. There it is. So I did create an array list called words, but you can see it's a null object, right? I haven't created the thing for it. Well, that's what this line of code is going to do. It's going to go ahead and create the actual array list, and this will cease to be a null object. So that happens here. So now when I look at it, this thing is actually an array list of words. I can open it up and I can say, oh, that's interesting. It's holding no elements. There's nothing in it yet, but some things are about to happen, because what happens next is I'm going to get an element. Let me put this right here. So when I hit step, what's going to happen is words.addTime is going to occur. That's going to increase this value to 1, meaning there will be 1 value in there. And when I open this up, I'm going to be able to see the actual words that are in the list. So let's go ahead and do that. Next. Boop. Yep. Ooh. Now that's interesting. It says protected int mod count. Oh, there it goes. It actually did it. So I do see that there is now time it was stored in there. That's not exactly what I thought would happen, but the dot size of this is 1. So now you can see I'm going to go ahead and add lunch. And because I'm just adding it without an index, it's going to append it. It's going to go to the next available spot. So this null is going to become lunch, right? There it is. Now we're going to use the set. Well, actually what we're going to do is, first of all, we're going to spin up a string called temp, and I'm going to do words.set1 to skunk. Now I'm not sure the order that this is going to do it. I think it's going to help do the set first. So what I think I'm going to see happen, let's just step it and then we'll look. So I'm going to hit step. Okay. So looked like everything just happened at once. So what happened was, this used to be the word lunch, right? But I set the one at index 1 to skunk. But remember, the return type for set is it returns the one that used to be there. So you can see temp spun up right here. It's a local variable, and it now contains lunch. And the very next thing that's going to happen is lunch is going to be inserted in this list at location 0. And when it does that, oops, get back up here. A couple things to remember that will happen is not only will it put it there, but it's going to append the list so that this spot 0 is going to become the temp value, which will be lunch again. But the other two elements are going to be shifted down by 1. So dot add at spot 0 says, yeah, I'm going to add it at 0, but when you do it, it keeps everything else and just shifts them down. So if I hit step, notice that lunch got thrown into location 0, and then time and skunk got shifted down. If I say dot add hexagon, that's just going to append it to the bottom of the list. So that's going to be there right there at spot 3. There's the hexagon. And then finally, I'm asking it to remove the word at index number 1. So what's going to get removed is time. And when it removes that, because this would be a null, skunk is going to shift back, hexagon's going to shift back. So we'll only have three things in the list at index 0, 1, and 2. And this one that currently lives at index 1 time is going to become my temp variable. So I hit step and you can see all that stuff happen. I picked up time is now in temp. Time was removed from index 1, and skunk and hexagon were shifted down. So the point of this is just to see that we have a powerful tool for manipulating lists, array lists in this case, large sets of data using just one variable, right? The one variable is words, and pretty cool. So now let's move on to the next part where I open up the tool so that we can look at a large set of words all at once without having to type them all. So I will remind you that I did ask you to import the java.io exception up at the top. And what we're going to do now is go ahead and create an instance of this tool that's in our project called word list tool. We're going to create an instance of this. And then this thing will be able to ask to give us a bigger list of words that will just automatically go into this class. So let's go in there and do that. So to do that, just right here after we're not going to delete any of this. We'll just leave all this here because Words is about to get a major revision. It's going to change. So what we're going to do is we're just going to say, I'll just do this. We're gonna do a try catch block, and it looks like this. This is not part of the AP subset, so do not worry about this. But I'm just gonna type the word try, try, and this is what I'm gonna try to do. And if that doesn't work, I'm gonna catch and IOEXCEP but I'm not gonna do anything really with that. It's just gonna I think I've spelled something wrong. IOEXCEP IO exception. And it's not carch, it's catch, CATCH. Nope. Let me try and type this slowly. CATCH. There we go. So we're gonna catch that. Let me just do this. Oh yeah, an IO exception E. There we go. And if this fails, the program's not going to work. So I'm not going to try to recover from it down here. But I think that's my understanding of a try catch block. If something doesn't work out, you can try to recover from that down below. But I'm just gonna know that this will work. And it should, because I've given you the list and everything should be set up just correctly. So in here, we're just gonna, it only needs to be localized to the try block. So I'm just gonna say word list tool, and I'll just call it WT, and it equals a new word list tool. And it doesn't require any parameters to be sent to it. You can look at the, oh, look at that showed up already. If you look at the constructor for a word list tool, it does throw an exception, but it doesn't require any arguments to be passed to it all. So we've got that all set up. And then what we're going to do is we're just going to say our list of words is going to equal, our list of words is going to equal, and I'll just say word WT for the word list tool. And look at it, it's a method called get words. And it's not, there's no description of it because I wrote it. And so hacky. So anyways, that's just grabbed a whole list of words for us, and now words is that. And just to demonstrate that something has happened, right? That it's not what it was before. I'm going to ask this thing to go ahead and I'll do this. I'll do a system.out.println, and I'll have it print words before. And then actually the list is going to be so long I won't even be able to see it. I'll just inspect it. So if I compile this, shrink this down. Oops, will that compile? No. Where am I not compiling? Where is my error? Let me find it. Oh, I got it. I have an extra brace at the bottom. Embarrassing. Happens. Okay, that looks good. Right click it, new words, got it. And you can see my everything that I just talked about before happens, and my list ends up being lunch, skunk, hexagon. Time was taken off at the last minute. But if I go ahead and inspect this object, right, you can see the private array list string called words, this array list. If I open it up, it's like, well, it doesn't have this thing would, to me, is like, dude, it should have 3 things in it, 0, 1, and 2, but I have 62 things in it. And that's because we just got all those from our word list tool. If I open it up, you can see here are all of the words that live in it, right? All of these. Oh, there's the word mask, beg, user, plastic, save, injury, comfort, pat, burn. Oh, that's great. Look at all those words. So here's what I want us to do. Now that we're set up, right, and you are ready for a programming task, I'm going to give you a couple things that I want you to do at this point. And what I want you to do at each time is you're going to have to report back some things to me, some things that are the results that you get. So all of the code you're going to write at this spot, I'm just going to have you, yeah, I'm just going to have it live right in here. So it's just going to live in here. And I think that's how it will work for the rest of the period. So go ahead and look at the Google Doc. Listen, I might have some additional instructions in class, but I think we're ready to go for the day.